In today's lesson, we're going to be finding the axis of symmetry. So if you recall, when we were proving the quadratic equation, we actually proved that if you have a quadratic in standard form, as you see here, we were actually able to express it in vertex form in this manner. Now we went ahead and that was about midway through the proof and then of the quadratic equation, but this is a very interesting result. By the way, those of you who missed the lesson on the proof of the quadratic equation and you want to see it, I'll link that in the top right hand corner. But because this is in vertex form, I know that the vertex of this quadratic in general would be negative b over 2a, and then the y-coordinate of the vertex would be negative b squared over 4a plus c. So the second coordinate isn't really that nice. It is useful because this is the formula for the y-coordinate of your vertex, but the first coordinate is used quite a lot, and it's a handy way to find your axis of symmetry of your quadratic, because I know that the x-coordinate of my vertex is my axis of symmetry, which means that if I have a quadratic in standard form, the axis of symmetry of this quadratic is in general going to be x equals negative b over 2a. So therefore, any quadratic you have in standard form, its axis of symmetry will be negative b over 2a. So that's a quick way of finding your axis of symmetry. Let's take a look at how we can use that to now express our quadratics in vertex form as an alternative method to completing the square. All right, let's look at our first example here. So for our first quadratic here, if I wanted to put this in vertex form, one of the options that we talked about was by completing the square. Again, if you missed the video on completing the square, I'll link that in the top right-hand corner. You can check it out. But at any rate here, instead of completing the square to put this in vertex form, what I can do is I can say, okay, well, my axis of symmetry is going to be x equals negative b over 2a. Well, my b value here, let me make that a little clearer here. My b value here is 6, so this will be negative 6 over 2 times 2 is negative 6 over 4 is minus 3 over 2. So that means that the axis of symmetry of this quadratic is minus 3 over 2. Well, what's my corresponding y value? To find the corresponding y value, just sub it back into your original quadratic and solve for y. So in this case, you have 2. When you square a fraction, you square the top, square the bottom. If you take a look here, this will reduce to become a 3. That'll become negative 9 minus 1. And likewise, this will reduce to become 2 at the bottom. That'll be a 1 and a 2. So if I clean this up here, we end up getting 9 over 2 minus 10, which is going to be 9 over 2 minus 20 over 2, which is negative 11 over 2. So the vertex of this quadratic is going to be minus 3 over 2 minus 11 over 2. Okay, now if we want to put this in vertex form, the main thing, and this is a really important result, is that your a value is the same. My a value will be exactly the same, but now that's everything I need. Because if I go to find the equation of my vertex form, the equation of vertex form is y equals a, x minus h squared plus k. But therefore, for our quadratic, it's going to be y equals 2, because that's my a value from my original standard form. It's going to be the same a value. And then I just need to insert the vertex into here. So this will be x plus 3 over 2 squared minus 11 over 2. And therefore we have our vertex, our quadratic, I should say, in vertex form. Notice this is actually a lot easier than completing the square. This quadratic had relatively messy vertex, and that would have been very difficult to complete the square with this expression here. Okay, let's take a look at the next question. So same idea here. I want to find my axis of symmetry. So my axis of symmetry here is going to be x equals negative b. This time b is negative 14 over 2 times a. You're going to get 7. So my axis of symmetry is 7. So now to find my y-coordinate of my vertex, I'm going to sub that into my quadratic here. And we end up getting, what is this, 49 minus 98 plus 5. You end up getting y equals negative 44. So I have my y-coordinate of my vertex and my x-coordinate of my vertex. So therefore, putting this together here, the vertex of this quadratic is going to be 7 and negative 44. But like I said, the a value is the same. The a value here, it's not written, but it would be a 1. So the answer to this quadratic is going to be y equals x minus 7 quantity squared minus 44. Okay, let's check out another. So same idea here. My axis of symmetry is going to be x equals negative b over 2a. So in this case here, we get a half for my axis of symmetry. Now I sub that into my original quadratic to find the corresponding y value. So I'm subbing that in. And in this case here, this will give me a quarter minus a half plus 1. And we better get a common denominator here. So this will be a quarter minus 2 over 4 plus 4 over 4. And my y value here comes out to be 3/4. So putting this together here, I have an x-coordinate of minus a half, a y-coordinate of 3/4. So my vertex of this quadratic is going to be minus 1/2 and 3/4. So now putting this all together, the answer to this, because again, it's going to be the exact same a value, right? Your a value will be unchanged. So my a value for this quadratic here, you'll notice the a value here is 1. So the answer to my quadratic is going to be y equals 1 times x plus 1/2 quantity squared plus 3/4. And then without having to complete the square, we've now expressed our quadratic in vertex form. Okay, let's take a look at the next question here. So for number 4 here, we want to express this in vertex form. This question here, you'll notice if you go ahead and find the axis of symmetry, this is already in vertex form, right? This is already in vertex form, so it's already done, right? And the reason to this question here, and the reason I asked this question is because you can have a quadratic that can be in standard form and vertex form, and even factored form all at the same time. Because, just by putting a minus 0, now technically I'm in vertex form, and here I was in standard form. Okay, so I thought I'd point that out when you're going through these here. If your b value is 0, you already are in vertex form. Okay, so continuing on here, I want to take a look at how do you express something in vertex form if you're not given standard form. Is there another way? Now, again, my options right now is I have a quadratic in vertex form. I can either expand this all out, simplify it, put it in standard form, then do negative b over 2a or complete the square, or I can find my roots here. So I'm going to go ahead and find my roots for this quadratic. So we're going to set y equal to 0. And if I set y equal to 0 here, I have the product of 3 expressions is 0. Again, the roots for this, and by now we've got a pretty good idea of that. This is going to be negative 3, and this is going to be 7. So my roots for this quadratic are negative 3 and negative 7. Now we know a lot more about this quadratic now. I know that the leading coefficient is positive. So if I wanted to do a quick sketch of this quadratic, let's say we just want a quick little sketch to get an idea of where everything's at here. I have a root at negative 3, another one at 7. Looks something like this, but the point being here is that the distance, if this is my axis of symmetry here, I know the distance across here is going to be the same on both sides. So I know the distance from here to here is the same. So therefore, if I average these out, I can get my axis of symmetry. So my axis of symmetry here is going to be negative 3 plus 7 divided by 2 is going to come out to be 2 for my axis of symmetry. So now that I have my axis of symmetry, that's the x-coordinate of my vertex, I can sub it back into my quadratic here, and I can solve for y, and we get negative 50. So now I have my x-coordinate of my vertex and my y-coordinate of my vertex. Putting this all together, my a value is going to be the same, so my a value will be 2. So the answer to this question here is going to be y equals 2 x minus 2 quantity squared minus 50. And now this is my quadratic expressed in vertex form. Okay, so we want to continue on here expressing our quadratics in vertex form. So again, for this one here, we want to go ahead and find the roots. So I'm going to set this equal to 0. Notice this is in factored form. You can rewrite that x as an x minus 0 if you wish, if it makes it clearer. And now from here, I have the product of two expressions as 0. Again, this minus a half is not contributing at all to making the product 0. So the only way this can be 0 is either x minus 0 is 0 or x minus 4 is 0, in which case x is 0 or x is 4. So now what I've done here is I've identified the roots. So we've just discussed in the previous example, if I go ahead and add these up together, I can calculate my axis of symmetry. So my axis of symmetry is going to be the average of these two roots, which is going to be 2. So now I have an axis of symmetry of x is equal to 2. I need to find the corresponding y value, so I sub it back into my original quadratic. So in this case here, x is 2. Everywhere I see an x, I change that to a 2. So it becomes minus a half times 2 times negative 2, and this will all simplify to become 2. So therefore, the vertex of this quadratic is 2 and 2. So if I want to put this in vertex form, well, I know my a value here is minus a half, so my quadratic in vertex form will be y equals minus 1/2 x minus 2 quantity squared plus 2. And you'll see here now you have your quadratic in vertex form. Again, the key to this is identifying the fact that once you have your vertex, your a value is always the same. The only thing you have to watch out for is you have to make sure that your quadratic is actually in proper factored form before we do that. And we'll look at some examples of that later on. Okay, so taking a look at the next question here, notice here, again, this is in proper factored form. So first thing is to find the roots, right? So like we've discussed already, the roots for this would be 2 and 7. So now if I want to go ahead and average these out, I can find my axis of symmetry. 2 plus 7 divided by 2. So you're going to get 9 over 2 for your axis of symmetry. So again, to find the y value for this, I have to sub it back into my original quadratic. So everywhere you see an x, we're going to change that to a 9 over 2, a 9 over 2. And yeah, it looks like it's going to be a bit messy here to clean this up, but not a big deal. So when you're taking care of this here, you're going to rewrite this as a common denominator. So I'll put that 2 as 4 over 2. And likewise, I'll rewrite the 7 as 14 over 2. And now going through our bedmass rules, we're going to take care of brackets first, in which case I get 5/2. And 9 minus 14 is going to give me negative 5/2. So now we have the product of three fractions. So we want to reduce where we can here. At least these 2's will cancel. And this will reduce to become negative 25 over 6. So it wasn't as bad as it seemed. So the vertex of this quadratic is going to be 9 over 2 and negative 25 over 6. So putting this together here, we can have our answer. And the answer for this quadratic here is y equals 2/3 x minus 9 over 2 quantity squared minus 25 over 6. And again, notice how much more difficult this would have been if we had to complete the square on this, right? Dealing with working with 9 over 2's and fractions of that nature can be a lot more difficult. So again, this was in proper factored form. And as we saw here, the 2/3 in this case was the same a value, be the same a value for our vertex form. Okay, now I want to take a look here at number 4. The reason why number 4 is interesting is because it's actually not in proper factored form. This right here is not fully factored, so it's messing up the value of a. So what I need to do here for number 4 is I'm going to have to factor out, there's a GCF of 2 I can take out of this expression, so I'm going to factor that 2 out, and this becomes x minus 3, x minus 5, and then, and only then, can you go ahead and use that a value. Had I kept an a value of negative 1, my answer would have been wrong. So you have to make sure that you're in fully factored form before you identify what your a value is. So at any rate here, I can go and answer the question now. My roots for this are going to be 3 and 5. Therefore, my axis of symmetry is going to be 3 plus 5 divided by 2 is 4. So I sub that into my original quadratic. You can sub it into this one or sub it into this one. It doesn't make a difference. I'll sub it into our sort of simplified one. So it's going to be -2. Everywhere I see an x, I change that to a 4. And in which case here I get -2 times 1 times -1 is 2. So the vertex of this quadratic is going to be 4 and 2. So now I can finally give my answer. The answer to this is going to be y equals my a value, which is -2, x minus 4, quantity squared plus 2. And you can see here, now I am in vertex form. Okay, so that concludes today's lesson here. I just wanted to point out that, again, there's other options besides completing the square to express a quadratic in vertex form. If your quadratic has roots, as we see here in example 3 and example 4, and 1 and 2, then you can just find the roots, average them out, find your y value. Once you get your vertex, you're just grabbing the a value. And likewise for these examples up here, completing the square is not necessary all the time because you can do the -b over 2a option, right? If you're in standard form, it's very easy and quick to go ahead and calculate that -b over 2a. All right, thank you.